Yeah, warm greetings to everyone. To start with, my name is V.S. Ranjit and I am currently pursuing my undergraduate degree in mechanical engineering at Coimbatore Institute of Technology. Today I am here to share some information about fused deposition modeling, and without any further delay, let's get into the topic. Yes, before getting into fused deposition modeling, let's see what is meant by additive manufacturing. Additive manufacturing is a free-form manufacturing process the that is used to fabricate a physical part by directly using with the help of a CAD model. And in additive manufacturing, we can see that the desired product is formed in layer by layer. Hence, it is also called as layered manufacturing or solid free-form fabrication. The major advantages of additive manufacturing is that complex geometry can be attained. The wastage of the material is very much minimal. It is a straightforward process and it is much quicker method of manufacturing. Modes of fabrication. To look into fabrication, we have mainly three major modes, namely subtractive fabrication, additive, and formative. In subtractive fabrication, a large solid is reduced by removing the material to the desired shape. It involves machining and grinding process. In additive fabrication, multiple layers or the raw material is combined together to form the desired object. Mainly it involves the welding, soldering and all the additive manufacturing techniques and processes. In formative fabrication, we use external load or force in order to obtain the desired shape and size of the product. Here mainly bending, forging, all the injection molding techniques are comes under the classification of formative fabrication. Then a overview of all the additive manufacturing process can be created on the basis of the raw material, a physical state of the raw material used. It can be solid, liquid or powder, and further classification includes, depending upon the process, can be an extrusion process, lamination, polymerization, binding, melting or sintering. And in this seminar I am going to spend a lot of time mainly focusing upon fused deposition modeling, its principles, its advantages and disadvantages. Yes, coming to additive manufacturing, all additive manufacturing involves these following 8 steps, 7 to 8 steps, from initial stage up to the product production. They are first designing of the CAD model, then the designed CAD model should be converted to STL format, then the slicing operation should take place, then the file transfer to machine should occur, machine setup should be carried out, then the physical model construction takes place, and finally the post processing, finishing processing is performed to attain the desired product. First, the CAD model. In CAD model production, we can use software such as SolidWorks, ProE, sorry. Then we can use many other softwares, other CAD Pro or CAD package softwares to produce a 3D model. Then conversion of CAD model to STL model. STL stands for Standard Tessellation Language, otherwise can be known as the extension for stereolithography. In the STL model mainly converts the CAD model to mesh of triangles to form a shell of the object. And mostly this conversion is performed by the CAD package, CAD softwares. Then the slicing operation. Slicing operation mainly converts the three-dimensional object into closely spaced two-dimensional cross sections. Yes. Mainly the conversion for to .stl format, because it does not require much data conversion and much geometric reasoning compared to other modes of other formats such as boundary representation or constructive solid geometry. Then we have to transfer the produced files to the machine through wired mode or wireless mode. And in the machine, visualization manipulation of the 3D model can be carried out prior to printing. We can carry out repositioning, or we can change the orientation of the part if required, or change the location of the model in the machine before carrying out the printing operation. Then the machine setup. Machine setup is mainly performed according to the raw material used in the printing operation, because in machining setup we actually fix the range of temperature to which the raw material has to be heated, so that to maintain a proper flow of the material through the nozzle. Then the physical model is built upon the print bed, and initial for the first few layer construction, the manual controlling and decision making is required, and once the machine has printed 2 to 3 layers, the machine can take over the control and carry out the operations automatically. And finally, the post process or finishing process. Finishing process is mainly depends upon the application or depend upon the product. Can be abrasive finishing, polishing, or just sandpaper finishing, etc., depending upon the application. And here we can see manufacturing of a cup, how a cup takes a form from its design in the form of software, then the slicing operation, then it is turned to a machine code, and the machine code decides the tool path in which it has to maneuver over the print bed to plot the desired product, then the actual physical printing process and post processing, and finally the application of the teacup is shown over here. Next, we can get into the topic of fused deposition modeling. Actually, as it is mentioned over here, fused deposition modeling is a non-laser filament extrusion process which mainly uses engineering thermoplastic as a raw material in order to obtain its finished product. And this technique was actually developed in late 1988 by the co-founder of Stratasys, known as Scott Crump. And major applications such as it can be used to form a prototype model shown over here, such as the casing, motor casing model, a fan blade model. Then we are taking a view at a gaming controller, which can be actually used as a finished product. Then we have a system of cyclic gears. All these are built by using FDM process. And the raw material ranges are, we have a wide range of thermoplastics such as ABS, polycarbonate, PPSF can be used depending upon the application and purpose. Then the principle. For FDM process to take place, one has to know the concept of surface chemistry, thermal energy, and layer manufacturing technology. And as mentioned in the previous slides, in FDM process also, a CAD file has to be created. That is, the 3D model of the required product has to be created as a CAD file. Then it has to be converted to .stl format. Then slicing operation should take place. Then the file has to be transferred to a machine code which governs the tool path of the print head, and by the relative motion between the print head and the print bed, the product can be constructed. It is the behind works, what happens prior, what has to be performed prior to the actual construction of the product. And if you see in physically what happens is there is a drive system which contains the raw material, which contains the spool of filament, which is driven into the heating coils by the help of the drive wheels. In the heating coils, the raw material is heated below its melting temperature such that it can flow easily through the nozzle, and it is pushed through the nozzle by the help of drive wheels, and the melt gets deposited upon the layer, and this process takes place continuously until the desired product is obtained. Then to see the basic steps, sequential steps of FDM process. First, the loading of material takes place, followed by liquefaction of material by the help of heating coils. Then by applying pressure, it is moved or pushed through the nozzle upon the printer bed. Then the plotting, yes, the machine code which is provided by the user governs the plotting path which the tool, which the print head has to follow, and the bonding between the material occurs due to the cooling of the layers, and a solid structure is formed. And in case if a complex structure has to be produced, supports can be used for producing complex structures or overhanging structures. Now let's take a look at the various parts of the FDM printer. The image shown here is a Cartesian printer. Let's discuss the types of printer in the upcoming slides. First, the main part is the control board or the motherboard. The control board actually acts as the brain for a 3D printer. It contains all the data, it interprets all the signals from the sensors, and it commands all the other components their respective operations which they have to perform. Act as an overall governing system for the printer. Then the motion controller. These are the effective components which governs the movement of print head, print bed, and all the accessory devices, accessory components which are required to carry out the printing operation. The motion controller can be in the form of belt or in the form of threaded screws, and any in the form. First we see belt. The belts are used for the movement to carry the print head along the X and Y direction, along the XY increase, along the XY axis. Then we have the stepper motor. Stepper motor provides the necessary movement for the print head and the print bed indeed. Then the end stops. End stops, they provide the boundary limit for the print head and the print bed so that their movement is restricted and limited within that boundary. The threaded rods. The threaded rods mainly govern the movement of the print head along the Z direction, that is vertical movement. The height of the print head can be adjusted using the threaded rods. But in fact, threaded rods can be replaced, can be used in place of belts, but they are a bit costlier than the belts. So belts are mostly used to govern the motion of the print head along the XY axis. Then the power supply unit. The power supply unit is mainly required for attaining the temperature required in the heating coils to melt the raw material. And when we come to print bed lights acts as a base for the product upon which it has to be built. And the print bed should be adhesive, in fact, to hold the product. And the print bed can be preheated to certain temperature in order to avoid the wrapping and shrinking of the first few initial layers of the hot raw material which comes out of the nozzle. As due to the temperature difference between the hot filament and the cold print bed, there is a greater chance for the occurrence of wrapping and shrinkage of the product, which destroys the profile of the product. Hence, print bed and the usage of adhesive glues can be recommended to avoid such wrapping and shrinkage problems. Then the extruder. Extruder, or otherwise called as the print head, contains major elements such as the heat sink, heat carriages, thermocouple, cooling fans, nozzles, everything which is required to carry out the printing operation. It has two ends, namely the cold end and the hot end. In cold end, it contains the driving wheels which pushes the filament into the hot end. Hot end contains the heating coils, cooling mechanism, and melts the filament and extrudes it through the nozzle upon the print bed. And the nozzle diameter is commonly of a standard size, generally of a 0.4 mm. Then the feeding mechanism. When we come to feeding mechanism, we can see two feeding system, namely direct drive extruder and a Bowden type. In direct drive, as we can take a look over here, the print head contains the driving wheel upon its top, and hence if we see the extruder as a unit, the weight of the extruder increases as the driving wheel is present upon itself. So the speed of the movement of the print head is limited. Hence the printing time is generally greater. In Bowden feeder mechanism, the driving wheels are located away from the print head, and the filament passes through the feed drive tube and reaches the heating coils. So it reduces the weight of the print head and encourages the faster movement of the print head, so that the time of printing can be much reduced. And it is the advantage of Bowden feeder over the direct feeder. Then let's take a look at the types of FDM printer. Mainly there are three types. One is the Cartesian type, Delta type, and Polar type printer. In Cartesian type, the print head moves along the XY direction, whereas the print bed moves along the Z direction. In Delta type, the print bed is fixed and the print head moves in all the three directions, all the three axes. In Polar type, the print bed is able to rotate upon the Z axis and is also capable of moving along XY direction, whereas the print head can move along the vertical axis, that is the Z axis. And for further classification and further comparison, we can take a look at the table. As initially mentioned about the print head and print movement. In Cartesian system, the location, in order to locate a point in a Cartesian system, three values about its X, Y, Z axis should be provided by the user. Whereas in Delta type, also X, Y, Z coordinates has to be provided. Whereas in Polar type, we have to give the angle, radius where the point occurs, and also the height and the vertical direction where the point occurs. Then the motor required, we can see for Cartesian we require 3 motors, Delta type also 3 motors. For a Polar FDM printer, just 2 motors is enough. The height of the build, there is a product produced in Cartesian has a limited height, whereas in Delta it is mainly used to build high structures or high products. Whereas in Polar type also the height of the product is very much limited. Then the cost. Cartesian, comparing to these three devices, Cartesian is the most cheapest, and it can be easily purchased. It can be serviced and maintained at ease. Delta, it is a bit costlier than Cartesian system, but comparatively less costlier than Polar type device. And Polar type is the costliest and rarely available, hard to maintain and service. When we come to accuracy, Cartesian FDM printers are able to produce highly accurate and precise products, because as it takes a prolonged time for printing, the accuracy and precision of printing is greater. Whereas in delta type, the accuracy and certain details of the product are lost during printing as it prints at a very high speed. Generally, the accuracy is a bit low. And polar type gives a moderate accurate products and with precise dimensioning and values. Yeah, let's come to the support material. Why there is a requirement of support? Yes, whenever there occurs a overhang structure which is greater than 45 degree, or structures like bridges or protruding surfaces greater than 5 mm thickness, support material is needed. The support material should be selected in such a way that it should be easy to remove from the product. It should be easily detached from the product and it should not cause any damage to the finished product. The removing methods of the support material can be carried by using manual removing by applying limited loads, or it can be dissolved in soluble solutions like water, or it can be detached from the product by using small range of vibrations, or it can be melted from the product without causing any damage to the finished product. The commonly used support material are polyvinyl alcohol, high impact polystyrene material. Then let's speak about the raw material. Generally, raw material are of a commodity plastics or engineering plastic or high performance plastic can be used to produce the end product. Depending upon the object strength, surface finish, high dimension accuracy, the raw material can be selected and it can be used to build the product. Commonly used raw materials are polyacetic acid, acrylonitrile butadiene, then thermoplastic polyurethane, polycarbonate can be used, and various other thermoplastic material can be used. Let's come into the application part of FDM. To be frank, FDM focuses on all the sectors of technology and provides its help for the development of technology. We can see its role in automotive and electrical housing component manufacturing, industrial equipment manufacturing, and its predominance in medical device manufacturing, drug packaging, aiding goods are produced, then plays a vital role in creating and modeling prototypes which are both functional as well as model, and has a key role in aerospace applications, aircraft interior replacement part manufacturing, and can be commonly used for tool manufacturing, tool aiding sectors such as production of molds, or jigs and fixture manufacturing. In all these sectors, FDM has its own upper hand and governance, and it's further developing in order to bring a vital change in these sectors. And as we can take a look at a model of 3D house built by FDM process, then a mold cavity, a die cavity for bottle, for a plastic bottle manufacturing. Then an electronic circuit board can be created by FDM process. Then we can see a pedal, which is a functional model, which has been created with the aid of FDM process. Let's come into the advantages and disadvantages of FDM process. FDM, as we can take a look, it is a cheap and easily accessible process, and it is a user-friendly device. It is a simpler mode of producing 3D products, and it can directly consumers can be benefited by these methods of FDM process. And the post-processing methods are also simple and easily can be performed. If we come to disadvantages, The quality and accuracy of the finished product when we compare to the product produced by SLS and SLA, it is very quite low, and the time of production is also very high. So it is not applicable for mass production in industry. Can be used to produce a small number of goods. It can be used for small number of goods for steady purpose or for prototyping purpose. But when it comes for commercializing or mass production, it doesn't has an upper hand. Yes, as previously discussed, wrapping and shrinkage prolongs to be a major issue for FDM process and destroys the profile of the product. And the raw material is very much limited. It can be used only to produce effective products using high grade thermoplastics. Only plastic material can be used. Does not have its operational range to metal and other non-metallic devices or non-metallic materials. So these are the advantages and disadvantages of FDM process. Now let's view the video upon the FDM process for further information about FDM process. And to conclude with, I thank everyone for your patient hearing upon my presentation, and I also thank everyone for providing me such a wonderful opportunity to share a piece of knowledge with all of you. Thank you and have a good day.